Hi dudes, now I'm here to explain a topic about single electron transistor. Single electron phenomena. Transistors are used as a tiny switch for tuning on and off. This is also used on transferring and amplifying signals, making logical decisions, etc. We can use single electron transistor to make sensitive amplifiers, spectrometer, switch, oscillator and other digital electron circuit. All these instruments will be operated by using electrons or quantum dots. Condition for single electron phenomena. We have to keep the single electron or quantum dot isolated. If any electrons on one side of the barrier could just tunnel across it, there would not be any isolation. This dot quantum dot because it would still essentially be part of the bulk, so we need to control the addition and subtraction. Rules for single electron phenomena. There are two rules for preventing electrons from the tunneling back and forth from a quantum. Coulomb blockade, overcoming uncertainty. Rule 1. The Coulomb blockade. We know that the Coulomb blockade can prevent unwanted tunneling. Here we can isolate the quantum dots is isolated. Rule 2. Overcoming uncertainty. For the second condition, to keep the quantum dot electronically isolated, we took the uncertainty principle. Single electron transistor. A single electron made from a quantum dot that controls the current from a source to drain one electrons at a time is called a single electron transistor. This is the structure of single electron transistor. Here we know that source to dot, dot to drain, source to dot and dot to drain. Difference between ordinary transistor and single electron transistor. The single electron transistor is bulk like a conventional FET. The difference is that instead of a semiconductor channel between is the source and drain electrodes, there is a quantum dot. The dot can be particles on an insulating surface. And this sandwiched between on insulator, even just the section of a semiconductor materials where the electric field effectively isolated electrons. Working of a single electron transistor. The purpose of SET is individual control the tunneling of an electron into and out of quantum dot. If an electron comes or goes from the dot, it will on purpose. To control the tunneling, we apply a voltage bias to a gate electrode. There is also a voltage difference between the source and the drain that indicates the direction of the current. Here we can say that the current and the electron flow in the same direction, and we will consider the electrons from which the electron originated. This is similar to working of FET, where the voltage creates an electric field that alerts the conductivity of a semiconductor channels below it, enabling the current to flow from a source to drain. Applying a voltage to a gate in a set create an electric field and changes the potential energy of a dot with respect to the source and drain. This gate voltage controlled potential difference can make electron in the source attached to the dot and simultaneously electrons in the dot attached to the drain is equal to VQ. Working of SET in null set. This set is off mode, then the corresponding potential energy diagram shows that it's not electronically favorable for electron in the source to a tunnels to the dot. This set is on mode. At the lowest setting, electron tunnels one at a time via the dot from source to drain. Once the electron is on it, the dot potential energy rise. The electrons then the tunnels through the Coulomb blockade on the other side to reach the lowest potential energy at drain. With the dot empty and the potential lower, again the process repeats. Thank you.